Okay, Joans Nursery specializes in custom design landscaping for residential areas. The estimated labor cost associated with a particular landscaping proposal is based on the number of plantings of trees, shrubs, and so on to be used for the project. For cost estimating purposes, managers use 2 hours of labor time for the planting of a medium-sized tree. Actual times from a sample of 10 plantings during the past month follow. With a 0.05 level of significance, test to see whether the mean tree planting time differs from 2 hours. Okay, differs from 2 hours. So we're talking about a two-tailed hypothesis test. We're assuming the average is 2 hours, and we're trying to see if it's not, if there is some other average. So some other average would be something less than or something greater than. So we are going to do a two-tailed hypothesis test, and we'll assume that the average is the claimed value of 2 hours. Now, the sample of 10 data points, calculating an average on that, I get 2.2 hours, and a standard deviation of 0.5164. Now, keep in mind the sample size is 10, so we're talking about a small sample. And we're using the standard deviation from that small sample. So, even more so, we need a t-distribution here. The sample standard deviation from a very small sample like that can't really be heavily relied upon to be close to sigma necessarily. So we're going to go ahead with a t-distribution. The second step is to go ahead and create the sampling distribution. In this case, it'll be a t-distribution centered at the claimed 2 hours. And we have a level of significance of 0.05, so we'll split that. So 0.025 on the upper and lower ends. And to calculate a standard error, we'll take, in this case, all we have there is the sample standard deviation, and then divide by the square root of the sample size 10. So putting that in the calculator, I get 0.1633. Now, to find the critical values, I need to go to the t-table. In this case, the area of the upper tail is 0.025, so that's the column I'll be looking at. The sample size is 10, so the degrees of freedom, remember, is to subtract 1 from that. So I'm in row 9 and in column 0.025. So I get a critical value of 2.262, and then by symmetry on the lower end I get a negative 2.262. And in step 3 I can create my rejection rule. I'm going to reject H sub 0 if my test statistic T is less than negative 2.262, or my test statistic is greater than 2.262. Okay, step 4. To calculate that test statistic, I'm going to take my sample average, 2.2, subtract my average that's been claimed, and then divide by standard deviation of the sampling distribution, or standard error of 0.1633. When I do that, I get 1.22. So that is not strong enough evidence to show that the average planting time differs from 2 hours. So I do not reject. h sub 0. We can't show that the average planting time is something other than 2 hours. Now, again, just a reminder, notice what that doesn't say. It doesn't say that the average time is 2 hours. It just says that we didn't have strong enough evidence to show it wasn't. There's a difference there, so you want to be careful. Do not reject does not mean accept. Now, the 1.22 t-value is less than the 2.26 critical value. So that basically means that my 2.2 sample average is just too close to call. It's too close to the 2 hour average as claimed by the null hypothesis. So too close to call here. The evidence isn't strong enough to get a rejection of the null hypothesis. Again, that doesn't mean that the null hypothesis is true. It's just the evidence isn't strong enough to show it's not. Now, what if I want to run this using a p-value? Well, first of all, I would set up the null hypothesis the same way, and I would calculate the test statistic 1.22 for my sample estimate of 2.2, and then I would try to determine, well, first of all, I would start with that 1.22, indicating that I'm a little bit too close to the center or the hypothesized average to get a rejection. Now, what I'll calculate for a two-tailed test as far as the p-value will start by finding the probability of being any further out than the 1.22, and to get that value I'm going to need to go to the t-table because this is a t-distribution, and I notice that for my sample size of 10, my first number in that row of the t-distribution table is 0.879, and my second number is 1.372, and that is where my 1.22 falls. It's right between those two. Associating the 0.879 to the column value, that's 0.20, and the 1.372 is 0.10. So my p-value, well, actually, this is a two-tailed test, so I've got to be careful. My p-value isn't going to be between those two values. But the area here that I've shaded, the area above the 1.22 location, or my test statistic location, is going to be between those two values. So my the way I'm going to get my p-value is I'm going to take those two values and multiply them by 2, and my p-value is going to fall between those two values. And the way I would write that is 0.20 less than p is less than 0.40. Now, that would give me a rough estimate of where my p-value is. It's something between 20 and 40%. If I use Excel to calculate the actual p-value, I'm going to get something closer to 0.2518, and that's going to be more accurate. And that value is greater than 0.05. So that would draw me to the same conclusion: do not reject h sub 0. I'm not willing, of course, to say that h sub 0 is correct. I'm just not willing to reject it either. There's not strong enough evidence that it's wrong. And as a matter of fact, the p-value is really made me even more confident in the sense that I'm not rejecting the null. Not only was I not beyond the 2.262 critical value, I was quite a bit closer to 2 than that. The p-value is giving me a feeling for where I am, what location I'm at in the sampling distribution. Where I would have allowed a 5% error, I've got a much higher probability of being in error if I reject the null. So certainly I don't want to reject the null. I'm a lot closer to what the hypothesized value is. And now I'm not willing to say the null is true. I'm certainly not willing to say it's false. So in some sense, this test is inconclusive. The p-value, bottom line, gives me a better feeling for where my risk probability is. And it's much larger than the allowable risk of 5% that I was willing to take. So no, I'm not going to reject the null. There's not strong enough evidence here to convince me that it's incorrect.